In this video, I want to talk about modeling data in a context where there possibly is an interaction between at least two covariates. So I want to talk about the Titanic dataset again, and I want to talk about it in the same way that we talked about it in class, where we try to kind of predict the probability of surviving based on the age and the sex of the individual. So how would you do it where there possibly might be an interaction? So you would say, okay, so the probability that survived I is equal to 1. So the probability that person I survived, well, you want to model it as logistic of beta 0 plus beta 1, perhaps you would say I male, so it's going to be beta 1 times 1 if person I is male, and this term is not going to be there if person 1 is not male. And then you want to also add plus beta 2, perhaps age, or you might like to use log age, probably would work better, but not the point. And you would say plus beta 3, possibly there is an interaction between age and sex, so this would be age times the indicator of whether the person is male. Okay, so this would be the model. Now, why might there be an interaction here? Well, here's one theory. One theory that people have about the Titanic is that people had this philosophy of women and children get saved first. So what you might imagine is that women of whatever age and young men, so basically boys, had a high probability of surviving, and grown-up males had a low probability of surviving. So that's the kind of theory that you might have, not necessarily true, of course. And what that would mean is that age would interact with sex. How would it interact with sex? Well, what you would posit is that basically if the person is male and if the age is large, so if the person is a grown-up male, then the that probability of surviving should go down, which means that beta 3 should be negative. Okay? And if the age is small, then this term shouldn't matter as much. And it wouldn't matter as much because age would be small, so even if beta 3 is large and negative, this term wouldn't influence things as much. So that would basically make the probability of surviving for men be lower than the probability of survival of boys. So that would be one theory why there might be an interaction that's like that. Of course, it would not necessarily be there. You'd have to look at the data and see. So, okay, what would be kind of the hypothesis? So one hypothesis that we might have where this is one possible model is, for example, that the probability of survival depends on age. If your main hypothesis is that the probability of survival depends on age, you would say that your null hypothesis is beta 2 is equal to 0. And then if you reject this null hypothesis, you would say, okay, the probability of survival does depend on age because we rejected this hypothesis. Now, if we're only interested in the age, what about the interaction? Well, what you would do is you would try to fit the model with the interaction, and you would try to fit the model without the interaction. How would you decide which one to use for which one to test this hypothesis? Well, you would check, for example, for the AIC coefficients for this model and for the model without the interaction, and you would pick the one that's better. You could also use cross-validation, again, to decide between the model with the interaction and without the interaction. After you've done that, you can test your null hypothesis, which is concerned with the effect of age on the survival. So that's one possibility. What's another possibility? Well, maybe actually what you're interested in is whether there is an interaction or not. So if what you're interested in is whether there is an interaction or not, your null hypothesis would actually be beta 3 is equal to 0. If your null hypothesis is beta 3 is equal to 0, then, well, first of all, you got to use this model. And second of all, once you use the model, well, you do a wall test on whether beta 3 is equal to 0, and that will tell you whether there is an interaction or there isn't. Or rather, it'll tell you whether there isn't an interaction, because of course, you can only ever reject beta 3 equals to 0. You can never definitely say that it's equal to 0.